Hello everyone, you're with Articles here again. So I'm back. So today I'm about to share with you how to construct the confidence interval for the grant mean using the Lsd, and also for each mean per treatment, and how to use the Duncan and the Newman curl, including the variance component and their intervals. So we can begin. So firstly, we'll need the MSE to do that, because when we talk about the confidence of interval it will need MSE is very much important in this concept. So let's find MSE first. So the easy way to find the MSE is to find the variance per each treatment. So what basically I'm going to do, I'm going to input my first data. So as you can see here, you can see 19, 11, 13, 14, 18. Then I'm going to press AC Shift 1. Then I come to option 4. So this is my standard deviation, simple standard deviation. When I square it, I'll get my variance. So S1 squared is 11.5. I'll also have to find my treatment. It's also important. The mean pay for each treatment. So the mean for this, it's y bar 1 dot is given by 15. Let me do for the second treatment now. Go back to my table. Then I input the values for the second treatment. AC again, Shift 1. So 4, I find the mean. This for the second treatment is 27.6. What about the variance for the second treatment? So my variance for the second treatment, as you can see here, is nothing but 2.3. Let me do the last one. It's 10. Okay, AC Shift 1. This thing is so the mean for the third treatment here is given by 15.6. So now the variance for so let me confirm my data for this one if it's correct. I have 10, I have 17, I have 15, I have 27. Oh, my data is correct. So I'll do this. Yeah, it's indeed. So the variance for this one was given by 51.8. So the easiest way is for you to find the variances and the mean per each treatment. Trust me, with this you never go wrong. So now we can find SSE. With the help of SSE, we can find MSE. So then we can construct our confidence interval for the grand mean. So in this case, we managed to find the variances for each and the means for each. So now, what is SSE? Remember, SSE is just the sum of Ri minus 1 Si squared, where Si all squared is the variance for each. So we can just calculate our SSE from here. So what we need, as you can see here, our replications here, there are 5. So since it's balanced, I'll take it as common. So 5 minus 1, it's 4. Then which means I must add the variances. So it's 4 multiplied into adding the variances. 11.5 plus 2.3 plus 51.8. So where I will get, so my SSE is 262.4. So now I can be able to find the confidence interval for the grand mean. So what is the grand mean? The grand mean is given by the sum of the 3 means divided by 3 since it's balanced. So it's 15 plus 27.6 plus 15.6 all divided by 3. I find my grand mean as 19.4. So now let us do the confidence interval for the grand mean. So I will have 19.4 plus or minus t of 0.05 divided by 2, the degrees of freedom of the error, which is in this case 15 minus 3, the square root of MSE. So how do I get MSE? I take this value of SSE, which is 262.4, I divide by 12, which is the degrees of freedom of the error. Then I'll also have to divide by the total number, TR, which is N. So how many? N is 15. So proceeding further, I'll get my T tabulated as this one. So it's very much important for you to calculate the variances per each treatment and the sample means per each treatment for us to be able to find the grand mean and also the SSE, which will lead us to MSE. So since we are about to construct the confidence interval for the grand mean, which is given by this, so in this case we're going to look for our T of 0.025 with the degrees of freedom of the error of 12, which as you can see is this value here for degrees of freedom of 12, and also alpha is 0.025 as you can see here. So proceeding further, now we can find our grand mean in confidence interval. So we have 19.4 plus or minus 21, then we multiply by the square root to 262.4 all over 12 multiplied by 15. So if you can note, this is the standard error for the grand mean. So my answer will be population mean greater than 16.769 and less than 19.616. So is the population mean because the grand mean is just the estimated population mean. Don't forget that this is our grand mean. So this is the confidence interval for the grand mean. So we're assuming our population mean will be between this value and this value, and that's how we conclude. So we are 95% confident that the population mean will be between 16.769 and 19.616. So this is our conclusion on the grand mean. Hopefully you understood. So the confidence interval for each treatment mean. So since it's for each treatment mean, this will be our standard error for each treatment mean. So we're still using LSD. So our t value will still be the same. So we'll just have to find the confidence interval for treatment mean 1, mean 2, and mean 3. So that's all. So the confidence interval for the first treatment is given by this: y bar 1 plus or minus, then 2.1788, then the square root of the MSE divided by 5, since we have 5 number of replications, if you can count here. So we get this. So which means my mu1 will be between 10.444 and also 19.556. So let's do for mu2. So for the second mean is given by this. So we'll find our mu2 to be between 23.004 and also 31.156. So let's do for 3 now. Lastly, the confidence interval for mean 3 is between 11,044 and 20,156. So we are done for the confidence interval with the grand mean and also per each mean for each treatment. So now we can move forward.